Okay, so then what lesson 4 does is kind of brings together real quick just some of the vocabulary we've been talking about with slopes. If the side lengths are going to be perpendicular, so intersect at right angles, the slopes would be, again, what we say is opposite reciprocal. Again, what I mean by opposite reciprocal would be like 2/5 and then change the sign and flip it, -5/2. Now, we haven't really got into parallel yet. I should have probably on this last 2, but we haven't really got into that. The side lengths are going to be parallel. The slopes will be the same, okay? So when I look back at example 3 here, when I look at the opposite sides that I found with their slopes, so like 1/4 and 1/4, well, that was 1/4 here, that was 1/4 here. Those sides are parallel because their slopes are the same. I should have referenced that back in the notes. The same thing is true with -7/2, -7/2. Turn out to be this side and this side. And because of that, we have ourselves, again, sides that are parallel, okay? So parallel sides have slopes that are the same. Perpendicular sides would have slopes that are opposite reciprocals. The only difference between a rectangle and a square is whether or not the sides are all equal in length. Okay, so example 5. All right, so our first 2 examples, we've given you guys a sketch. We're now starting to take that off a little bit, kind of take away your training rules. A sketch is not always necessary, but a sketch can help kind of give you a nice visual of things. So in this instance, that's what I would do first. Plot those points. This is our first time through, and typically as we work throughout this unit and out this year, we kind of keep taking away some things, but this is your first time seeing it. So we go ahead and give you some structure to help you guys through things. Because I don't know if you guys have ever seen some of this stuff before. And there is a lot of stuff going on. So if you haven't done so yet, go ahead and find the length of, say, AB, BC, CD, and DA. So pause it, go find your links, and then we'll come back together. So I'm just going to go ahead and use my graph since I have a graph here. I can see that this is a length of 3, this is a length of 3. Pythagorean theorem it, and I eventually get 3√2. And I can take care of the slope at the same time. Now, if you don't want to graph it out, you don't have to. You can just go straight to using your distance formula as well. You can use your slope formula as well. Again, I don't really care how you get those lengths, as long as you can get them properly. Now, when I did the slope of AB, I went down 3 and over 3. That is -3/3, which reduces down to -1. Please make sure you always give me a reduced form, -1. And let's repeat that for BC. BC, I'm going to get 3√2, and I'm going to get a 3/3. I've done this one for many years, so I know what these answers are. 3√2. That's going to be -1. And then DA. Okay. Now, let's classify the shape. If we only found the side lengths, a lot of people would say, oh, yep, it's a square. And I play devil's advocate, and I say, well, why can't it be a rhombus? Because a rhombus has all sides that are congruent. So does a square, but a rhombus does too. So what determines the difference between the rhombus and a square is, do I have right angles at the corners? Are the adjacent sides perpendicular to one another? So in this instance, when I look at things, when I get length of AB, when I get a slope of AB is -1, okay, that's -1, and I get a BC length, BC slope of 1, which is right here, that's where I'm bringing in that opposite reciprocals, okay? -1 and +1 right here. -1 and +1 are opposite reciprocals of one another. So that means these have to intersect at right angles. And then that's true at all the other pairs as well. So the shape turns out to be a square because first off, all sides are congruent. And if you just told me that, I'm going to mark it half wrong. Because if you just tell me the shape is a square because all sides are congruent, and that's all you told me, and you didn't do the work for slopes, I'm going to mark it half wrong because I could say, oh, it could also be a rhombus. All sides are congruent for a rhombus. So then finish off by saying, and adjacent sides are perpendicular because adjacent slopes are opposite reciprocals. That tells me a nice quick explanation of what you're talking about, okay? Now, the perimeter of this figure, four sides of 3 root 2. So the perimeter is going to be 4 sides of 3 root 2. This is using 3 root 2 plus 3 root 2 plus 3 root 2. Okay, eventually that gives me 12 root 2. Now, this is an SAT question. We call it a grid response. You cannot type in a square root in here, okay? So this is where you need to go to your calculator and type in 12 root 2 and then plug in what you can. I get this decimal of 16.970 and so on. So realistically, what I could get into those 4 columns is going to be, in this case, 17.0. The reason why I say 17.0 is 16.9716.9. Okay, that's 4 of those. So then I look at that that number 7 that's not inside the column. That tells me around 9 up. And then because it's 9, it tells me around the 16 up to 7. So that's why I said 17.0. And if we were taking the SAT right now, you most definitely have to bubble this in. Or when the computer grades it for SAT, it would not grade that. It only grades the bubbles, not just filled up boxes right here. The area of a square we've talked about before is the side squared. 3 root 2 squared. We've done a lot with Pythagorean theorem. And eventually we get what? 8